Hello. I wanted to make a quick video regarding the calculus exam, the calculus final. So I wanted to go through each one of these problems just step by step, just so we have one more kind of anchor point before we actually get to the final. So I'm just going to go ahead and go do that. All right. So the first question, limit as x approaches -3 of negative x squared plus 3x over x plus 3. Okay, so normally in a limit, we are plugging in this limit into x, right? So if we do that, we do -3 squared plus 3 times -3 over -3 plus 3. And you should notice that both the numerator and denominator go to 0. But the important thing here is that the denominator goes to 0. Okay, so when our denominator goes to 0 of a limit, that means we have some kind of work to do. Don't necessarily know what that is, but we have something else to do before we can actually evaluate that limit. The first thing you should always try is to factor a common factor out, right? And when you do that, that is called a removable discontinuity. So if you just try and factor the top or bottom, the top is factorable, right? The greatest common factor between x squared and 3x is x. So if we just factor out an x, right, we get limit as x approaches -3 of x times x plus 3 over x plus 3. And in this way, right, x plus 3 is a common factor. So those can cancel, right? That's just 1. And we're left with the limit as x approaches -3 of just x, right? So then we try plugging in our limit again, and we just get -3. For number 2, this is evaluating the limit at an asymptote. Okay, so this is something that is not removable, right? And again, we would start as normal. We plug in our limit, plug in 3, right? So 1 over 3 minus 3, and that's going to be 1 over 0. Okay, and this, again, is just a cue to kind of do a little bit more work, okay? But because there's nothing to factor here, we have to look at this question a little bit different of a way. All right, so we have to look at the limit as x approaches 3 from the positive side, so from the right, of 1 over x minus 3, and the limit as x approaches 3 from the negative side, right, so from the left of 1 over x minus 3. Okay, so when we're doing this, we're taking the right-handed limit and the left-handed limit. And if those things agree, then that is the limit. If they do not agree, then the limit does not exist. Okay, so if we just take numbers really close to 3, but from the positive side, we would get 1 over something like 3.1 minus 3. All right, so when we do that, we get 1 over 0.1. Okay, and I'm not worried about magnitude here. I'm worried about what's happening as this number gets really, really close to 0. Okay, so if this thing in green goes really, really close to 0, our denominator goes close to 0. So if you have 1 over something incredibly small, you grow toward infinity. Okay, so this right-handed limit is infinity. It's positive infinity. All right, if we do the same thing for the bottom, the left-handed limit, right, this time we're coming from the left, so it'll be something like 2.9 minus 3. And that'd be 1 over negative 0.1, which the same behavior occurs, except this is negative. All right, so now, because these two things do not match, our limit does not exist. If they were the same, then each of these things would, then both of these things would be equal, so then that would be our limit. Okay, but in this case they don't, so the limit does not exist. Number 3, use the definition of a derivative to find the derivative of each function with respect to x. So if you remember back from last semester, the definition of a limit, the definition of a derivative is the slope of 2 points really, really close together. Right, so if you understand that concept, you really understand taking most of derivatives. Everything else is just kind of an expansion of that. But our actual definition is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Right, where delta x is the distance between these 2 points, f of x plus delta x could be, let's say, this point, and f of x is just this point, right? So if we take the slope of those 2 points, we get what our fraction looks like right here. All right, so then if we just try and do that, right, we get the limit as delta x approaches 0, f of x plus delta x is negative 2x plus delta x plus 5. And then f of x is just negative 2x plus 5. And then all over delta x. Okay. So that's the first step, is just getting f of x plus delta x and f of x. Then we have to simplify. So we get negative 2x minus 2 delta x plus 5 plus 2x minus 5. If we combine like terms, right, negative 2x cancels 2x, positive 5 cancels negative 5, and we're left with negative 2 delta x over delta x. Delta x is a common factor, so those cancel, and we're just left with negative 2. So then that is the slope, that is the derivative based off of the definition of derivative. And that should make sense, right? If we just take the derivative of this as we normally would using the power rule, we would just get negative 2. Okay, so we can always check that. Number 4, differentiate each function with respect to x. So this is using all of the rules that we've learned, right? So product rule, quotient rule, chain rule, all those things are fair game. Right, so this is a product of 2 things. So we need to take the derivative of the first thing times the second plus the derivative of the second thing times the first. Okay, so that's how we set it up, but then we actually need to take the derivative. Okay, so this derivative of 4x cubed plus 3 to the 5th, right, we got to use the chain rule there, so this becomes 5 times 4x cubed plus 3 to the 4th times 12x squared, and then times 2x to the 4th plus 1, plus the derivative of 2x to the 4th plus 1. Right, so that is 8x cubed, then times 4x cubed plus 3 to the 5th. Right, and we could continue, we could, expand all of that and combine like terms and all that, but this is all I'm looking for, right? So if we just get here, we're good. All right, so number 5, for each problem, use implicit differentiation to find dy dx in terms of x and y. Okay, so this is essentially just the chain rule, right? So we take the derivative of each of these things in terms of x, and we'll get our answer, right? So if we take the derivative of x cubed, and I guess I can set this up. And there's a little bit going on before you get to this point, right? This is really the derivative of everything to the left, but we can separate that into 2 separate ones because there's a sum inside, but we'll end up getting here. Okay, so then the rest is just taking derivatives. The derivative of x cubed is 3x squared. The derivative of 2y squared, right, is the derivative of 2 times something squared, which is 4 times that something just to the first. and then times the derivative. So I'll write it like this for now, of the inside. All right, and then the derivative of 3, that's just going to be 0. And then we're going to be left with 3x squared plus 4y to the first, so just 4y. And then times d dx of y, which is just dy dx. And again, we could solve for dy dx here. It's not very difficult. Nothing different is happening, just algebra. But if we get to this point, we're okay. Number 6, evaluate each integral. All right, so what I like to do is I'd normally like to separate this out. Right, so if we use some of these rules just to separate this entire integral, we get negative the integral of negative 1 to 3 of x cubed plus 2 times the integral from negative 1 to 3 of x squared, and all these should have dx's. And then plus just the integral of negative 1 to 3 of 2. All right, so then we're just using the power rule. All right, so the integral of x cubed, that's x to the 4th over 4, and there's still that negative out front, plus 2 times the integral of x squared, so that integral is x cubed over 3, and then plus the integral of 2, which is just 2x. Right, so this is our integral, but we need to evaluate this from negative 1 to 3. So then all we have to do is we have to plug in 3, we have to plug in negative 1, and then we subtract those things. Okay, so when we do that, we get negative 3 to the 4th over 4 plus 2 times 3 cubed over 3 plus 2 times 3. All right, we're going to get some number there. And then we subtract what happens when we plug in negative 1. Right, so negative 1 to the 4th over 4 plus 2 times negative 1 to the 3rd over 3 plus 2 times negative 1. All right, so we just carry this out either on a calculator or by hand. It doesn't really matter, but we get a number for this entire thing. Okay, and that number is, let's see, negative 3 to the 4th, that's 81. So that's negative 81 over 4. This is 2 times 3 squared, so this is 18 plus 6. And then minus 1/4 minus 2/3 minus 2. And then again, right, we could either add or subtract these fractions or plug it into a calculator. So if we do that, we get 15/4 minus 35/12. When we subtract those two things, this should be minus a negative 35 over 12. And when we do that, we get 20/3. So 20/3 is the answer I would be expecting. Obviously, you would get a lot of credit if you just got up until here, but I think we should be able to simplify those. All right. Number 7 and 8, both have to do with u substitution, right? So when we're doing u substitution, we're trying to cancel out something. All right, we're trying to make u equal some higher order such that when we take a derivative, we're able to cancel out everything else, right? So in this case, I'm going to let u equal x squared plus 1 du, right? If we take the derivative of that, we get 2x dx. So if we rewrite this, we take the integral of 2x dx over u squared, right? And you should notice that du is equal to 2x dx, which is right here. Okay, so that goes to du. So we can rewrite this as du over u squared and then that part is done. Like that's the u substitution. Then we have to change the limits of integration, right? So we just in order to do that, we plug these limits into our u, right? So 1 squared plus 1 and negative 2 squared plus 1. Right, so our brand new integral is the integral from 2, so the integral from 5 to 2 of du over u squared, which I'm going to rewrite as u to the negative 2 du. Then we just take that integral using the power rule and evaluate as we would for a definite integral, right? So this would be u to the negative 1 over negative 1, which is equal to negative 1 over u, evaluated from 5 to 2. So then this equals negative 1/2 minus negative 1/5. So negative 1/2 plus 1/5, which again, we can add fractions. It's just 3/10, negative 3/10. And that is our answer for that. Okay. Then number 8 is kind of the same idea, except we have a trig function involved, right? So if we do this, I'm going to let u equal all of this inside. So let u equal 3x squared plus 5. So du is just equal to 6x. All right, so if we rewrite this integral, notice there are no limits, so we don't have to worry about that part. This is just an indefinite integral. But if we rewrite this integral, we get the integral of negative 6x sine of u times dx. And again, you should notice that 6x times dx, well, that's just du. And also there should be a dx right here. Right, so du is 6x dx. Okay, so then we can just rewrite this as negative sine of u du. Oops. Which then is something we can kind of handle, right? So this is the integral, or sorry, this is negative integral of sine of u du. Which is negative and then negative cosine of u, and then plus c. All right, so this ends up being just cosine of u plus c. All right, and then that's our indefinite integral. Okay, so we do still need to know the integral of sine integral of cosine. And if we're able to do u substitution, this usually works out, or at least in this case, the cases that we're going to work with, this is going to work out just a little bit nicer. Okay, so that is the entire practice exam. This is practice exam 2, by the way. This can be found in On Campus right now, if you want to try this kind of on your own. Okay, so that's the entire practice exam. If you have questions, please email me, and I'll try and make myself available for the actual final. All right, thank you.